Okay, this is just called the sum and difference rules, but to me it's just the sum or difference rule because of this and this. That the derivative of f of x plus or minus g of x, this composite function, is simply the derivative of f of x plus or minus the derivative of g of x. It sounds kind of weird, but it's actually really, really reasonable. Let's look at this for a second. Here's an example. Let's let f of x equal 7x, if you don't mind, plus 3. Well, without doing any calculus, maybe we can say that f prime at x, which is the slope of this line is just 7, isn't it? Okay, let's start with this ending here, if you don't mind. We know that the slope of this line is 7. Well, let's look at this for a second. Now what we're going to do is we're going to make this function composite, and we're going to say that it's in two parts. Let's call this part of it f of x. I know I already used f of x, but pretend I didn't, just for fun. As a matter of fact, if that's bothering you, we'll call this h of x. How'd that be? H of x. All right? And so that makes this g of x, if you don't mind. So look at this for a second. I want to know what the derivative of this whole thing is. So h prime at x, the derivative of the function is the same as the derivative of 7x. In this case, look at this. Plus, why plus? Because it says plus. Plus the derivative of 3. So this is all I've done here. So I've taken these pieces, I've just taken this in parts, partition this out a little bit, and let's ask ourselves, first off, we already know that the slope here is going to equal 7, isn't it? Well, what is the first derivative? So h prime at x. The derivative. What is the first derivative of 7x? What's the slope of 7x? Well, it's 7. Now forget about this for a second. What's the derivative of 3, right? So now we're just looking at this, and this is y equals 3. It's a line that looks like this, isn't it? Y equals 3. What's its derivative? What's its derivative? What's its slope? Its slope is 0, isn't it? So plus 0. So h prime at x is just equal to 7. I think that makes pretty good sense. All right. Wow, we're still on. Okay, sorry, buddy. Let's look at this again. Sorry, I thought I'd lost you. Actually, I almost deleted this thing. So here it is. All right, so that's that example. Let's just do one more quick example. Now, when this would become more meaningful to you is when you had something like this. Say, let f of x equal x squared. Let's make it x cubed, yeah? X cubed plus 2x squared plus 7x minus 3. So all we're going to do here is we're going to go in and we're going to differentiate this piece by piece. So we're going to say f prime at x is equal to, well, what's the derivative of this using the power rule, right? It would be 3, right? This 3 comes to here, so 3. This gets decremented by 1, so not x to the third, but x squared, right? Then we'll do this piece. This plus sign right here is this plus sign right here. 2 times 2 is 4x, right? Now it's 2 minus 1 is 1, right? I'm going to do this piece. So this plus sign is this one, and it's 1 here, so 1 times 7 is 7. 1 minus 1 is 0. X to 0 is 1. 7 times that is that. This is, right, let's do this last piece right here. And the way I usually think about this, I think of this as x to the 0. So 0 times 3 is minus 0. That doesn't matter much, does it? So here's where we just did here. So we used the power rule, and we used the sum and difference rule. And, oh, and look, and we use the constant multiple rule. So good for you. Excellent work. I hope it was helpful.